So we're now going to look at graphs of secx, cosecx and cotx. So first of all, I'm just going to define what they are. So secx is the reciprocal of cosx, so it's actually just 1 over cosx, and cosecx is 1 over sinx, and cotx is 1 over tanx. And since we've got the identity for tanx is sinx over cosx, we can actually have the reciprocal of that for 1 over tanx. So it's also another way of defining cotx is that it's cosx over sinx. So what we want to be able to do is be familiar with the graphs of each one of these. And one of the things we need to be able to do that is know where these graphs are undefined. Now, undefined means when we're dividing by 0. So if we divide something by 0, then it's in infinity, which means it would be undefined. So if we look at when is secx undefined, so secx is undefined when, since it's equal to 1 over cosx, secx is undefined when cosx equals 0. So if we think about the cosx graph, cosx, if we're talking in degrees, so just remember if it's in radians, then we just need to know the equivalent of each one of these degrees. So this could be either that in degrees or pi by 2 in radians, pi, 3 pi by 2 and 2 pi. So a cosx graph goes through at 0 degrees and then crosses at 90, which is -1 there. So a cosx graph looks like that. And so since secx is 1 over cosx, then it's going to be undefined at 90 degrees and 270, since this is cos. So what that enables us to do is draw the secx graph. So got 90, 180, 270 and 360. What we'll have is, where it is undefined, we're going to get asymptotes. So just like on the tan graph that we're familiar with, we're going to get an asymptote there corresponding to cosx equals 0, and an asymptote there corresponding to also cosx equals 0 at 270. We can then try and get some other points. So because secx is 1 over cosx, we'll take some of the values that we know. So we know that for the angle is 0, cosx is 1, and that actually means that we're going to be dividing 1 by 1. So it's going to go here. And we also know that when the angle is 180, it's going to then, cos is -1. So we're going to have 1 over -1, which is going to mean that we're going to go through at that point. And similarly, at 360 degrees, since cosx is 1, then 1 over 1 is still 1, but a positive 1. So these are some points it's going to go through. But we can see that as we approach 90 degrees from the positive side, or from below, we can see that this cos graph is positive but getting smaller, which means that we're actually going to divide by an ever getting smaller number. So as the denominator becomes smaller, the overall value of this will become bigger. So we'll actually increase in value there. As we approach 90 degrees from the above 90, we can see that cosx is negative. And so the answer is always going to be negative, but divided by a negative number, which is smaller, means that the overall value is going to increase. So we're going to approach the asymptote from this side. Same thing happens as we approach 270 degrees. We're dividing by a small negative number, which means we're going to get a large negative number as the value for 1 over cosx. On this side of the 270 of the asymptote, you can see we're dividing by a small positive number as we're approaching 270 from above. So that means as we divide by a small positive number, then the overall value of 1 over cosx is actually a large positive number. So we approach the asymptote and we're going up towards infinity. If we're now doing the graph of cosec x, we need to remember that cosec x is actually 1 over sin x. So cosec x will be undefined when sin x is equal to 0. So if we draw our sin x graph, then that will look like this. And so where is sin x equal to 0? Well, it's 0 degrees, 180 degrees, and 360 degrees. So cosec in the range 0 to 360 is undefined when sin x equals 0, which is when x is equal to 0 at 180 and 360 degrees. Or if we're talking in radians, it'd be 0, pi, and pi by 2. 2 pi, I mean. Okay, so if we want to draw a graph of this, again, we can first of all draw the asymptotes. So the asymptotes are going to be at these points where it's undefined. So it's undefined at 0, it's undefined at 180, and it's undefined at 360. And then let's pick some values that we do know just to get a couple of points. So at 90 degrees, then we divide in, we can say that cosec x at 90 degrees is actually 1 over the value of sin x at 90 degrees, which is, so 1 over sin 90, which is 1. Change that to a 90 there actually, since I'm doing it for 90 degrees. It's 1 over 1, which is just 1. So at 90, there we've got that point there. And to find this point here at 270, so cosec 270 is going to be 1 over sine 270, and we can see that that's 1 over minus 1, which is going to be minus 1. So we've got another point here at minus 1. And we can see that as we approach 0 degrees from the positive side, so from 90 we're going towards the 0, we can see that sinx is actually very small and positive. So since cosec x is 1 over sin x, as sin x is becoming small and positive, then we divide it by a very small positive number, which means that it's going to become a large positive number. So we're going to approach the asymptote and get bigger. We also get the same effect as sin x approaches 180 from below. It's dividing by cosec x is 1 divided by a very small positive number, which again will give us a very large positive number. When we look at it from the other side of the 180, so this side of the asymptote, then we can see we're dividing by a very small negative number, which means we get a very large negative number. So we approach the asymptote and we go towards minus infinity as we approach the asymptote. Similarly, as we approach 360 degrees here, well, we've got a very small negative number as we approach 360. So we're dividing 1 by a very small negative number, which means cosec x will become a very large negative number. So we get this shape. For cotx, it's a slightly more complicated situation. So again, we need to know, well, cotx is equal to cosx over sinx. And so if we consider both of those two graphs, the sinx looks like this. And the cosx looks like this. So from them, we can work out what the cotx is going to look like. So first of all, let's look at where it's undefined. So it's going to be undefined when sin x is equal to 0. So that would be here, here, and here. So 0, 180, and 360. And so first thing we can do is draw the asymptotes at those points. So we've got asymptotes here along the y-axis at 180 and at 360. And also we can say, well, when the cosx, the numerator of this fraction, is equal to 0, then actually cotx will also be equal to 0. So we know it's going to cross at this point and at this point. So we know we've got asymptotes and we know some of the points where it crosses. So we need to then decide, is it going to look like this, or is it going to look like this? So from the information we've currently got, we're not exactly sure. So we need to sort of investigate the situation. So we can see that from 0 to 90, both of these graphs are going to be positive. So we can see up to this point here, both, so from 0 to 90, both cosx and sinx are greater than or equal to 0. So what that means is then the whole value of this fraction is going to be positive. So we know we're in the positive side of this. So we know we're going to be like that. And then when we look at in the range 90 to 180, we can see that sine is going to be greater than 0, and cos has actually gone below the axis there, so cos is less than 0. So what we've got is a negative number divided by a positive number, so the outcome is overall negative. So we could say in that range, cot is going to be negative as well, so that's going to be less than 0. So that shows us that from 90 to 180, there being 90, we're going to actually drop down below the axis there. If we then look at in the range 180 to 270, this point here, we can see, well, in that range, sinx is less than 0, cosx is less than 0. So that means our overall fraction is a negative number divided by a negative number, which is going to be positive. So we can say cotx is going to be greater than 0. It's going to be positive. So that shows me that we're approaching this asymptote from the positive side there. So we're going to be like that. And then if we look at this final quadrant from 270 to 360, we can see that we've got cosx is going to be positive, cosx is greater than 0, sinx is less than 0. So overall, we're going to have a positive divided by a negative. So cotx is also going to be negative. And that fits in with the shape of the graph because it's going to dive down negative as it reaches the asymptote.